Good afternoon or good morning, whichever one you're in. So today we're going to be talking about some population calculations because that's going to be our topic for the last part of this chapter is population growth. So we're going to be looking at some of the raw data today. So first off, we've got this country, doesn't matter where it is. Their population is 2.3 million people 10 years ago, back in 2010. Their area, the size of the country, is 800,000 square miles. And since 2010, they've had 109 people die and 111,000 people that have been born. All right, so we're going to use this to calculate some information. So first off, the population density. So to find population density, and the formula's here and on your assignment today, so you don't have to search for it, we want to take the population and divide by the area. So in this case, that would be 2.3 million, which is 2,300,000. And divide it by the area, 800,000. But it's not just the numbers. We also need to look at the units of measurement. The 2.3 million was a number of people, and then the 800,000, that would be square miles. So if I went ahead and divided those, 2.3 million divided by 800,000, I get a population density of 2.875. That's the number. Now, we want to put some words with that, and that's where we're going to go back and use this information right here. 2.875 people, and then fraction bars are always read as per square mile. Essentially meaning about every square mile, there's about 3 people who live in that whole area. So it sounds like people are pretty spread out here. This must be either a really large land area or a relatively small population of people for that size land area. So, and this is how we compare, how many people live in a small section. So, for example, if you looked at the population density of China, you would expect it to be pretty high because, again, the large number of people jammed into some smaller spaces. Or if you looked at populations of countries that are a little more spread out, like Canada, think about all the space in Canada that no one can really live in. So their population density is much smaller. All right, next, look at birth rates and death rates. So again, same information, same country, and we're going to look at the birth rate and the death rate. So to do it, we needed to the number of births or deaths per year. And I threw a little trick in this question that I did not put on your assignment. But in this question, notice that the deaths and births are since 2010. So since it's now 2020, you would actually have to divide those numbers by 10 to get the number per year. So again, I went ahead and did that for you right there. So we're using those numbers, again, after dividing each of them by 10. All right, so to find the birth rate, we're going to take the number of births. And in this particular case, the number of births was 11,000. All right, we're going to divide that by the total population, which was, again, that 2.3 million number. So if I did that, 11,100. I missed that number. That's 100. 11,100. And I divide by 2.3 million. I end up with 0.0048. All right, now, there's going to be 2 things we do with that particular number. One thing we can do is we can take that decimal and move it 2 spaces to the right and say that we have a 0.48% birth rate. All right, but then there's something called crude birth rate. That is where we take that decimal, 0.0048, and we times it by 1,000. Or essentially, we move the decimal a third space. And that is called the CBR 4.8. Just moving the decimal an extra spot. All right, so let's do the same thing for the death rate. There was 10,900 people per year that died here out of 2.3 million. So again, that's 10,900 divided by 2.3 million. And I'm getting put in the wrong spot. I got 0.0047. So again, to change this to a percent, I'll do 0.47%, and that'd be the death rate. And then there's this other thing that we need it for the next problem. This crude, whoops, not birth, the crude death rate. We move that decimal one more spot, or take the original decimal times by 1,000, not 100. So move that decimal one more spot than we did for the percent. And that's the crude, whoops, death rate. All right, we're going to need that crude birth rate and crude death rate for the next portion. All right, so the next portion is the population growth rate. So to find the population growth rate, what we're going to do is take some of those pieces of information we just found, that crude birth rate, minus the crude death rate. So the crude birth rate, if you remember from the last problem, was 4.8. So that means we are going to take 4.8 minus the crude death rate of 4.7 and divide by 10. That's going to give us 0.1 divided by 10. 0.1 divided by 10 equals 0.01. And that is the actual percent. We don't have to do any more changes. So we're talking about a 0.01% growth rate. And that's because the number of deaths and the number of births are relatively similar. They aren't very far apart. I mean, look at this back here. We're talking just a difference of 200 people per year out of 2.3 million. So again, it's a pretty small amount that we're using here. So that's why that number is low, 0.01%. All right, last thing. In how many years will the population double? And this is what we talked about just yesterday, this doubling time formula, this rule of 70. So again, to do that, what we're going to do is we're going to take that 70 and divide it by our growth rate, which we just got on the last problem, 0.01%. So if we take that 70 and divide by 0.01%, we're going to get an answer of 7,000 years. So in 7,000 years from now, this population will have doubled. And that's, again, it's going to lead us into what we talk about on Monday as we finish up this chapter. All right, let me know if you need any help. Again, all the formulas that we used here on this page are also on today's worksheet or your Kami page. So you don't have to have these memorized. You don't have to come back to the video. All the formulas are there on the assignment itself. All right, again, good luck.